All right, so taking a shift, we're going to start looking at going the opposite direction. So up until this point, we've been finding derivatives. I give you the function, you take the derivative of that, we do some stuff with it. Now we're going to look at, well, what happens if you have the derivative and I really want the original function? So the first thing we're going to look at is we're going to do a couple quick problems. So what's the derivative of that? So y equals x squared, right? What's the derivative of that? It's going to be the exact same thing, right? It doesn't matter what number I put over here. It just disappears anyway, correct? So when we're looking at going from a function to the derivative, we lose information. We lose those constants at the end. And the farther I go, if I did another derivative of it, I could possibly lose more information. So if we're looking at being able to go from the derivative, so now if I want to go from here to there, I have now not only one answer, I have a family of answers. Okay? So that's why whenever we're doing the derivative or the integrals, the function actually becomes the function of x plus c. You always have to add a plus c on the end of it, unless it's a definite interval. So that's because we don't know what that value is. We would need other information to be able to determine exactly what that one was. Okay? So that part makes sense. There is a lot of calc teachers that will literally mark things wrong if you don't put the plus c. So just keep that in mind. Yeah. What's your name? What was your first name? What was it? Antonio. Okay. All right. Now I've officially given out all the tests that have names on them. All right. So let's just look at a couple quick things. So I've got my f prime of x is sine of x. So what would be f of x? So so the question is which
negative cosine.
Right, which derivative, if I took the derivative of it, is going to give me sine of x. So remember for the sines, for the trig functions, it was sine of x, cosine of x, negative sine of x, and then negative cosine of x, right? And then repeat. So sine of x, if I'm going to go that way, goes that direction. Goes to negative cosine of x plus c. Don't forget the plus c. If f prime of x is 1 over x, what's f of x? So what derivative is going to give you 1 over x? ln of x. Oh yeah, I forgot. It's a bad calc teacher. I forgot the plus c. Plus c. So what about this one? Almost. So let's look at a problem. You're almost there. Very, very close. So if I took and I had x to the fourth, f prime of x would be 4x to the third, right? Okay. If it was x to the fifth, it'd be 5x to the fourth. If I wanted to go backwards from that, what do I have to do to my exponent? Add 1. So if this was x to the n, that's going to be n plus 1. So now the question is how would I get rid of that? Because I didn't want that there. Right. That was the one mistake you made. I'm going to divide that by n plus 1. You took the test, right? You didn't write your name on it.
Oh, I didn't?
Can you write your name on it?
Yeah.
And then give it back to me so I can put the grade in? Sure. And then I'll give it back to you at the end of class. Maybe. All right, so that's in essence the opposite of the power rule that we've been doing. Yeah, I gotta put the grade on. Because I had two, you can keep that. I had two people that didn't take the test and I couldn't figure out which one it was to do. So I'm like, I'll find out when I go to class. All right, so every derivative has an integral to undo it. Just like every function has an inverse to go back. It's the same concept there. Some things are more complicated than others, and that's where you're going to start learning in Calc 2. You'll learn the rules for how to do the product rule and how to do the quotient rule and the different trig rules and all those other things. If you look in the back of your textbook, or even online, you'll see that the page for the rules for derivatives is like 1 page. The pages for the integration is like 5 or 6 pages. There's like 190 different rules. So there's a ton of rules out there that you can see to be able to undo stuff, all right? Because unfortunately, undoing things is harder than actually doing it. So, but the power rule actually is one of the easy ones. That one actually comes up quite often. So it's just you're going to add 1 to the exponent, and then you divide by the n plus 1 because you want to get rid of whatever number was in front of that case. All right. So here are some of the rules. So let me actually make this a little bigger, then I'll scroll. All right. So constant's the same. If there's a constant multiplied by it, it's going to be no different. You can plot a constant multiplied by it. Addition, do the derivative of each, or do the integral of each of the pieces. That's the same. Subtraction's the same. Multiplication, division is not. You cannot necessarily just do the pieces of it. Just like in derivatives, you can't just do the pieces of it to get it. The power rule, as long as n is not -1, because that would be 1 over n. And what happens if you add 1 to 1 over to -1? You get 0. And that would disappear. That's actually why the ln rule works. That's why 1 over the derivative of ln of x is 1 over x, because it doesn't work for the power rule. So again, that's that one. The 1 over x is ln of x. E to the x is e to the x. No difference there. The integral of bx is bx over ln of b. Because if you remember, the derivative for it was what it was times ln of that value of the base. So the integral has to get rid of that ln by dividing by it. Cosine of x is sine x, because remember it just goes backwards in that rule, that 4 steps. Got those? because there's more. So a lot of these, some of these you're going to use, some of these you're not. Sine of x is negative cosine of x. We just saw that a minute ago. The derivative of tangent of x was secant squared of x, so the integral of secant squared of x is tangent of x. Secant x tangent x is secant x. You'll notice it's like if you just switch these two, you'd have the derivative table. Nothing has changed in this. We have the arc sine and the arc tangent ones. You're probably, we're not going to, I'll tell you right now, I'm not going to do any problems that involve this on the tests. You will see some more of that when you get into Calc 2 if you take Calc 2. And then the hyperbolic ones were the same concept. So remember cosine and sine, the hypercosine and hypersine to swap basically, and they do the same thing for the integration. So hypercosine is sine of hypersine, and then hypersine is hypercosine. This heat's getting to me. Oh my God. And I look, none of the windows open. Can I open a window? Nope. There's no handles on them. All right. So let's look into some problems. So actually, I'm going to rewrite this. So we've got g prime of x is 4 sine x plus 2x to the fifth minus square root of x over x. So first thing you're going to want to do for this is kind of rewrite it so that it's just all addition and subtraction, so we don't have that division in there. I will tell you that was the biggest mistake people made on their test, was algebra. So I have 2x to the fourth minus x to the negative 1/2.
Wait, it's minus x? Why is it minus x?
Well, that's the minus. So that stays.
Oh. Wait, I know where that went.
And then I did x to the 1/2 minus 1, which is negative 1/2.
Wait, it's x to the fourth equals x out?
Yep, same thing in there. Is the x to the fifth minus 1.
Oh. So the x would be, the x from the denominator would be...
Gone.
Oh, really? Oh.
I divided both of them by it. I did 2x to the fifth divided by x minus x to the 1/2 divided by x. Because remember, as long as you can't split up addition and subtraction in the denominator, but you can in a numerator by just putting the denominator under every piece. So it's kind of the opposite of what you do when you get common denominators to put them together. So this is where the same things are going to come true in integration as with the derivatives. You have certain rules that you can use. If you can manipulate the problem and make it simpler, manipulate the problem to make it simpler. Sometimes it's easier to do other ways. Sometimes it's easier to simplify it down like this. In this case, you don't have a ton of methods on how to do integration yet. You really have the power rule, which is all we talked about, and the ones like the actual set rules. So we kind of don't know derivative or dividing yet, so we can't really use it. And trust me, when you actually understand how to do the dividing, you're not going to want to use that if you don't have to, because it's a mess. So we've got this. So what's the derivative of, what's the integral or the antiderivative of sine of x? Negative cosine of x. Okay? So the 2 stays. Now what happens to the x to the 4th?
Fourth become x to the fifth, and that will be 2/5 x.
So x to the 5th, and then I divide by 5, right? Because I do 4 plus 1. Okay, minus. What's x to the negative 1/2? It's going to be x to the 1/2 divided by 1/2, which, yes, is going to become 2. I'm writing it out right now. I'll simplify that in a minute. So, unlike the power rule for derivatives, it's really easy to screw these up. Because the power rule for derivative, you bring the exponent down and then you subtract 1. So the numbers are different. When you're doing the power rule integration going backwards, you add the 1 and then you use that number. Okay? So those numbers will be the same. All right, so now if we can clean this up some. So I got negative 4 cosine of x plus 2/5 x to the 5th minus 2 square root of x plus c.
How do you get that negative root?
What's negative? There's 2 of them.
The negative 2 square root of x.
Okay, well the x to the 1/2 becomes the square root of x.
Oh.
And if you're dividing by 1/2, you're really doing the exact same thing as multiplying by 2. Remember, it's keep change flip. So the bottom thing flips over, becomes 2. That's also one that's going to come back quite a bit, is dividing by fractions, that you have to remember to flip those fractions over. Wasted money and killing students. Jeez. All right. Let's look at this one. So I've got f prime of x is e to the x plus 20, 1 plus x squared to the negative 1. And they also give me this. So why they gave you that is that's going to allow us, remember I said we have the plus c, unless they give me more information, that's the more information. So now that they've given me that, I can use that to find what c is at the end. Okay? All right. So let's clean this up a little bit. We're going to get rid of that negative 1. All right, so all I did was I got rid of the negative 1 and made it a fraction. I purposely did not put the 20 inside of it because if we go back and look at my wonderful little rules here, we have 1 plus 1 over x squared was one of the rules. So if you can get something that looks like one of those, get it there, because now I got the derivative of it. I mean the integral. It's the arctangent. So the integral of e to the x is e to the x, and then that's going to be 20 arctangent of x. plus c. All right, so now I've got f0 equals -2. So they want us to find c to get that exact value of the function. So we're going to plug in 0. So I got e to the 0 plus 20 arctangent of 0 plus c. What's e to the 0?
1.
What's so remember, arctangent's the opposite, right? So what angle is going to give you 0 for tangent?
Pi over 2?
No, pi over 2 is infinity, actually. It's 0. So 20 times 0 is 0. So plus c. So if I minus 1 from both sides, -3 equals c. So my total function is e to the x plus 20 arctan of x minus 3. And that's my final answer. There's no way to turn it off. I've looked. It's got a thermostat over here, which I've also tried. Just walk outside for a minute. I don't know if it's much better, but yeah. And the thermostat set down to 67. It's like the thermostat says, keep it at 67 in here. I can't even turn down the fan. Sledgehammer. Unfortunately, if the circuit breaks, it tends to just run. Yeah, I'm gonna call him tomorrow because this is ridiculous. There's just no way.
It's set to 69.
Yeah,
No any lower.
and it's just running.
So,
There's obviously something wrong.
power wire turns up to each
Yeah.
other. Also makes the outside air weak. That's back. I don't know why it's there.
Yeah, it's 37 outside. All right. Find me f prime of x. I got 2 more problems after this one, then we're done. Oh, I lied. I have one more problem after this. Because then I was going to make some problems up. All right, so what's our derivative of this one? Because we're on the second derivative. So what's the first derivative? So we've got the 12. X squared becomes, yep, x to the third over 3. And notice how I'm writing this. I would do this to start. Okay? Like, yes, 12 divided by 3 is 4, which you could do, but I would get in the habit of writing like this thing out there first so you can get used to what it means, especially then if you go back and look at your notes, go, where'd the 4 come from? It's like if you have x to the third over 3, you're going to make that connection. So I would definitely do that to start. So then the x becomes x squared over 2. What's the minus 4 become? Yeah, minus 4x. Because remember, there is a x to the 0 here. That's why you don't have to write it. So what's 0 plus 1? Is 1. So that's where you get the x back. All right, so now we can clean this up a little bit before I go to the next step. 4x to the third plus 3x squared minus 4x plus c. All right. Find my next one. Now take that, and again, do the integral of that one. All right. So what's the next one? So I got 4. Yeah. Almost. What did we do to the constant in the last problem? Yeah. This becomes cx plus d. I still have to add a constant. Because think about it, if we did the derivative, now if we just took this function right here, if I did the derivative of this, that d would disappear. And I would just have c because the x would disappear. And then if I did the derivative again, that c would disappear. So as we're going backwards, we got to add those features back in. So f of x equals x to the fourth plus 3x, oh, not 3x, just x to the third, minus 2x squared plus cx plus d. All right, and now I've got I got f of 0 equals 4, and f of 1 equals 1. So since I have to find 2 letters, I need 2 pieces of information to do it. Okay? Which one would you like to start with?
Just go on the band-aid to do CX.
Think about the ones I got. I got f of 0 equals 4 and f of 1 equals 1. which one of the two numbers could I plug in that's going to get rid of the most stuff? The 0. So start with the 0, because everything with an x is going to disappear, except for d. So f of 0 equals 4. So that's 0 plus 0 minus 0 plus 0 equals d. So now I know what d is. So I have x to the 4th plus x to the 3rd minus 2x squared plus cx plus 4. Now plug in the 1, because again, I don't want to get rid of my x in this case, because I need the x, I need that c to stay there, so I can't get rid of that. So that's why you need something with another number there. So now we can plug in the 1. So I've got 1 plus 1 minus 2 plus c plus 4. So 1 plus 1 is 2 minus 2 is 0 plus 4 is 4. So I got 1 equals c plus 4, so negative 3 equals c. And I'm just going to erase this and write the function right underneath it. So my final answer is x to the 4th plus x to the 3rd minus 2x squared minus 3x plus 4. That's my final function. That's why it doesn't matter when you're with the letters, you just always add the c, because the constant, if you're going to find it, the sign will take care of itself. So. And every time you do an integral, you have to do the plus c or the plus d. What'd you do?
I'm like, where did D go?
Oh, it was above it. D's there. All right, one more. So remember when we're looking at particle movements with acceleration, velocity, and those things, your position, or s of t. Then we have velocity, which is v of t, which is s prime of t. And then we have acceleration, or a of t, which is the second derivative of my particle. So they gave me a of t is 6t plus 4. And then they told me v0, or my velocity at 0, is negative 6. And they told me my position at 0 is 9. And they want to know what s of t is. So technically, this stuff here isn't needed for the problem. That's just I wanted you to remember the breakdown of it all. So this is one of those places where this is really used. So especially when you think about velocity, because if you're looking at a car, velocity is something we measure. We have that information. So you can easily make a graph of your velocity, or you can easily make a graph of your acceleration. Getting the position is not necessarily that easy to do sometimes. So those other two, these two we tend to have, and then find that. All right. So step 1, find me my velocity. Start there. Abraham, don't die on me yet. Don't die on me yet. We're almost done. I know the heat's killing us. I that was the first thing I looked at. Like, okay, maybe one of these. I looked at everyone, none of them bumped. Huh? Yeah, I know. Like, I could probably open one, it just won't shut again. And with tomorrow's rain, it probably will be bad. Like, my computer's heating up. Like, the back of it's like insanely hot right now. All right, so what's my velocity? So 60 over t, that, plus 4t plus c. So 3t squared plus 4t plus c. And we know that the velocity at 0 is negative 6. So I can now, in essence, that's my c. Because everything else is going to disappear except for c, right? 3 times 0 is 0. 0 squared is 0 times 3 is 0. Plus 4 times 0 is 0. So the only thing left is c. So this basically ends up meaning that c is negative 6. So my velocity is 3t squared plus 4t minus 6. So sometimes, like the last problem we did, all the information they gave you was at the end. It was that full function. In this problem, they gave me 2 different values, but they gave it to me for each of the parts. So you're not going to do that at the end, you're going to do that individually. So we have the velocity, we now find the c right there, so we don't have to worry about c in the next, well, we still have a c, but we're not going to have cx. So the last thing we have to do is do the derivative of this, or the integral of this one. I got to get used to saying integral again. So this becomes 3 to the third over 3.
Oh.
It's 4 t squared over 2
Okay.
minus 6t plus c. So S.
Use a different variable.
Yes.
Use the second one.
You could. Yeah, you could use any letter you want.
Yeah. I didn't. Teachers were yelling. Use C twice.
Yeah, you can use technically anything you want. I understand that though, because like technically we already have C, but since it's a different problem, it doesn't. Like in this part, when we did this one here, using C again would be bad. That's why you have to use D in this case. And this one, since we already found the C and the C is gone, I wouldn't necessarily have a problem with that, but some people are picky. I don't have a problem if you change the T to an X. So
You can just use a statement that's just like assume T
is X. Exactly. And then we're good.
and then at the end you just hold it back.
Yeah. All right. So there we've simplified it down.
be the same too.
Yeah, the 0 is going to cancel out everything except for the c, so c is 9 in this case. So then my final answer, my position vector is 2t squared minus 6t plus 9.
Is it plus 2t squared?
Oh, that's plus 2. Yeah, I actually probably wrote that. Literally the screen is hot.
That's okay.
I'm actually like feeling like the screen is hot. So it's like it's ridiculous.